Welcome back to React Native Radio Podcast. Brought to you by the No Meeting. What are the best meetings? No meetings. Episode 222. The New Architecture with Kevin Gozali from the React Native core team.
Mazen, did you get all your Christmas shopping done already, or are you kind of a late shopper?
I'm definitely a late shopper. I can never really decide what I'm going to get, so it usually takes forever.
Yeah, I mean, it's more difficult than, I don't know. It seems like, this would be a fun thing, like, get to go out, and I've got 4 kids, right? So you also get to see sort of the gamut of how difficult it is to shop for some versus others. Interestingly, my son, he's going to be turning 17 pretty soon, and he's been pretty easy to shop for. But my girls, who are like, 13, 10, and 8, been a little more difficult. I don't know why this year.
How do you stay on top of what gifts to get for them? That's the hardest part for me. Not that I have any kids yet.
I have a very organized wife. She's very, very good at this stuff, and I really lean on her and appreciate how organized she is, because that's not me. I'm glad. In this case, she kind of can cover for my skill gaps here.
I have a window that has so many tabs sometimes that I can't even see what each tab is. And come Christmas time, I'm usually overwhelmed by the amount of tabs, and I just go with the first 2 or 3.
We have a Slack actually that I set up for our little family. And so I actually put the kids in there too, but we have a separate channel. I should actually just make a channel for each kid for just my wife and I, so we can put the gift ideas in there, but it ends up being DMs. So,
that works.
My dad actually just rolled out his website. He's been working on this for about a year. And so I'm going to give a little plug for that, beardshollow.com. He's like a woodworker. He's a retired pastor, and he went into woodworking afterward. And so that's a good place to get gifts. I don't know if there's any inventory left by the time someone looks at it.
I just looked at it, and there's not a lot of inventory, but I am going to be scouring the site for a little bit till one of them comes back in stock for sure.
Oh yeah, don't say which one, otherwise someone will snap it up.
Exactly. Or I should just lead everyone to the other item.
To the wrong one? Yeah. No, I'm really happy he did that. My sister built a Shopify site for him, and he's been kind of obsessing about this for a long time. But yeah, it's pretty cool to see him get into this, and it's something totally new for him.
That's awesome.
Cool. Well, I am Jamin Holmgren, your host and friendly CTO of Infinite Red. I'm joined today by my terrific co-host, Mazen Chami. Mazen lives in Durham, North Carolina. He's a former pro soccer player and coach, current coach, not pro coach, but you are coaching, right, Mazen?
Kids.
Yeah. Kids coach, and is a senior React Native engineer here at Infinite Red. How's it going, Mazen?
Going well. Cold, chilly day.
We also have a very special guest today, Kevin Gozali. Kevin is an engineering manager in the React Native team at Meta, who has been managing the React Native team for about, I think, over 3 years, and has been developing software at Meta for 7 years, including working on the Ads Manager app in React Native for iOS and Android. He has an MS in electrical and computer engineering from Carnegie Mellon University, and has worked at Microsoft, 24/7 Incorporated, and other companies before joining the Meta team. Welcome, Kevin.
Hi, thanks for having me.
Yeah, I'm really excited to have you on. By the way, 24/7 Incorporated, does that mean you had to work 24/7?
Not exactly. That's just the company name. It's an interesting one.
Oh, yeah. Yeah. Well, that sounds like that's been a little while ago, though. You've been at Meta for quite some time now.
I've been here for over 7 years. Funny enough, first team I joined at Meta, or Facebook at the time, was as manager. That's basically the first ever app built with React Native before we open source it. So yeah, I've been here doing React Native since 7 years ago.
That's cool.
That's amazing, because that's prior to React Native being available publicly.
Exactly. I witnessed the open sourcing of that 2015.
We were aware of React Native when it came out sort of in, I think it was like the spring of 2015. And then we were doing native apps at the time. And then when Android came out, that was I think in September, we jumped on board, and that's just been like our focus from then on, basically. So it's been fun. I think it was version 0.17 or something that we jumped on.
That's cool. Yeah, September 2015 is the right time for Android.
We started the company officially in October. Before that, I had a previous company, so it was like right after. It was great timing. Anyway, very warm welcome to you, Kevin, and I really appreciate you coming on board. This episode is sponsored by beardshollow.com. No, just kidding. It's actually sponsored by Infinite Red. Infinite Red is a premier React Native design and development agency located fully remote in the US and Canada. If you're looking for React Native expertise for your next React Native project, hit us up. We have real React Native experts, not just React devs that are, put forth as React Native experts. We've been doing this a long time. And now I just pissed off our audience. Just React devs. I better not do that. We're good at it. Go to our website, infinite.red/React Native, and don't forget to mention that you heard about us through the React Native Radio podcast. We are hiring also. If you're a senior level React Native engineer located in the US or Canada, go to careers.infinite.red. All right, let's get into our topic for today. And this is something that we've had a ton of requests for. I mean, people really, really want to hear more about the new architecture of React Native. So my first question for you, Kevin, well, first off, you're involved in this, right? Like you're actually working on the new architecture yourself? Yeah.
I work on this every day.
So this is something you know pretty well. When I say new architecture, what does that mean to you? Because I've heard things like Fabric, TurboModules, JSI, Hermes. What comes to mind for you?
Yes. So the new architecture actually involved many parts. I think there was a bit of maybe misunderstanding that, Fabric is the new architecture or TurboModules is the new architecture, but how do they fit together is an open question. So to us, new architecture is the whole rewrite of React Native from the beginning of time when you initialize React Native all the way until something renders on the screen. So there's a lot of parts in the spectrum, and we categorize the new architecture into 3 parts. Phase 1 is TurboModule, the new native module system. Phase 2 is the renderer, Fabric, as you all heard about. And the final part is initialization path, the new startup path. That part is still on the works. We're still actively experimenting in the main Facebook app. And the purpose of that is to finally allowing us to remove the bridge. So
remove the bridge,
yes. So how's that going to happen? We introduce also a layer called JSI, JavaScript interface, to help us interface better with the JS engine. So you don't have to have this heavyweight JSON compatible message passing queuing from either side, native and from JavaScript. So the new architecture relied more heavily on JSI so that we can do direct communication on either side from either direction. So this is how things are connected. So when you hear JSI, you hear all this thing, TurboModule, Fabric, and removing the bridge. They're all connected. They're not separate projects. We're just doing it in phases. And then, of course, there's this thing called codegen. Maybe people heard about React Native codegen. What is it? So this is not an actual runtime feature. This is the way for us to provide type safety for every part of the new architecture. So for TurboModule, when you write a new native module or when you write a new native component for render Fabric, we generate code from JavaScript to ensure type safety. And this is the way we ensure that typing, naming, and like lookup are all consistent throughout. So all of these terms that I just mentioned is part of the new architecture, all of them.
Wow.
That's really helpful. And I think that's the first time I've actually heard it explained that way. So I appreciate Kevin. I've heard all these things kind of floating around, and I'm in the core team or the open source core team Discord and stuff. And it's still been slightly foggy for me. And that really clears things up.
That was a great explanation. I have a quick question on all those phases. Can we consider them as one package or are they separate?
Very good question. So initially, when we started the new architecture, we thought that, okay, let's just rebuild everything and then ship it in one go. After months of experimenting, we realized that, okay, this is actually very big pieces together. And it is very, very risky if we just roll everything out together because, who knows what's going to change in some part of your app. Like we want to make sure that backward compatibility is achieved and stuff like that. So if we just flip the toggle for everything, then there's a number of risks that may show up. And then we decided, okay, let's roll this out phase by phase. So we ended up rolling out TurboModule, like the new native module system first, in the entire Facebook app, iOS and Android. And then the renderer, the Fabric side, we finished that after, I think a few months after. So we finished that earlier this year, in the middle of the year. And then now we're on the next phase of the initialization path. Now, the nice thing about this approach is that we can work on the multiple phases in parallel. So there are some people in my team working on just TurboModule, some people working on just the render Fabric, and there are other different people are working on the new initialization path. And that helps us figure out everything that we need to know. Let's build it together to make sure that things are aligned. So, we don't really want to produce a system that feels very different, on different phase. And then let's figure out how things are connected. So for example, Fabric actually requires TurboModule to some degree because there are the model of the native to JavaScript communication that needs to happen in the same way. And then the new initialization path also will require Fabric and TurboModule because it doesn't make sense for us to revamp the init path using the old system.
Right.
Because, there's a lot of open risks and combination that doesn't matter in the future. So to answer your question, to summarize the answer, we do it in phases. The most important one for people eventually to move to is the first two, which is the native module and the renderer. The init path is somewhat more transparent. It may require some changes on your app level. It's not going to change your React components.
Okay. TurboModules is something that's been really interesting for me. I like the native side of things. I like to kind of work with that integration back and forth between the two. So I've been really excited about TurboModules just because I like working with the native side of things and the integration between the two. But I have this sense that are you writing code in C++ or can you still use Objective-C, Swift, Kotlin, etc.?
Yeah, the answer is yes and no. So the old native module system actually relied on the native code to explain what you can access in JavaScript. So for Objective-C, you write Objective-C classes, you have a macro, RC for module, RC for method. For Java, you have the annotation processor, and then you annotate your method, stuff like that. And then during runtime, we load classes and information up front, and then we tell JavaScript, hey, you have all this method and modules that you can access. So TurboModules simplifies this by reversing the direction. So the problem with having native telling you what is available is that you have to load all the classes pretty much in the app startup. And for a big app like Facebook, that slows down everything during startup. Therefore, we need to make it lazy. How do we make the discovery of this registration lazy is by reversing the direction. We use JavaScript to let you define what API you want to expose. And then we use a kind of semi-automatic registration so that we can tell the system, hey, when next time, if someone look for a module A or component B, here's how you look it up. And then just use that going forward. So everything is lazy by default for all of the new architecture. Which is good for app startup if you have hundreds of modules and components. And, let's be real. I think class loads in Java is very expensive for low-end device. You can spend seconds class loading. Yeah. So this is, given that what you write is JavaScript typing. We use Flow just because the company use Flow for now and React use Flow. To generate what is your API? Let's generate the binding. The C++ binding to translate how you call from JavaScript into native. So the C++ will take care of translation to Objective-C method calls and Java method calls and vice versa. So the layer that generates this binding is the codegen. So you don't write any C++ at all. You write typing in JavaScript. We integrate with the codegen automatically so that you don't have to write an invocation of codegen. And then the code we produce is C++ binding that you don't have to touch it. Objective-C interface protocol, that you can adopt in your class, and then Java abstract class that you can inherit from in your class. So your module implementation just need to conform to that generated classes or spec. We call it spec. And then things should be available during runtime. So technically, we can produce any class that we want. We can produce C plus the base class or nothing at all. I mean, you can set it up like as you like. You can customize how the lookup happen, and you can provide your own like C++ only implementation using JSI, like direct JSI, whatever you want. And we can probably also produce Kotlin base class, Swift base class, whatever you have, like C#, anything. That's the intention going forward.
Yeah, that's really cool. It blows my mind a bit. And I've been doing quite a bit. Our last or one of our previous episodes was about React Native Cololoco, which is a build tool that I made so that you can co-locate your Objective-C files and Swift files and stuff with your JSX files and stuff. And so you don't have to like be putting stuff in your Xcode project or your Android Studio project. It'll link those. It's basically auto linking, but for individual native files.
Yes.
I was really curious when I was building this how the new architecture was going to affect this. So that'll be something I'll definitely be keeping a close eye on.
Yeah, definitely.
So now that we've covered TurboModules in the first phase, phase 2 you mentioned was Fabric. What is Fabric? And as a developer, can I use that today?
Yeah, good question. So Fabric, for the sake of naming convention, we start to call it the new renderer. Fabric is just a code name that we spin up before. So the new renderer aimed to solve the underlying issue with threading model in React Native. So if you know, in the past, React is kind of synchronous. So React Native force everyone to be asynchronous in all the communication native to JavaScript. That means any part of the UI kind of measurement needs to be always async from both directions. This is fine for most cases, but you start hitting some limit when you have some very corner use case where you may see flicker because everything is asynchronous. So we're not waiting until layout is ready. We're just like, okay, we're done. Move on to the next thing. So you may see like a 1 frame or 2 frame artifact. Sometimes for example, when you first load React Native, you may see like, oh, it flicker with some resizing and vice versa. This is not just about the initial load. Sometimes when you need to do synchronous layout, when you are in the list, like a long list, you may see some artifact, just a 1 frame artifact of, things are not ready. Maybe 2 frame, maybe more, depending on your device. So this is a limitation in the old architecture. With Fabric, we aim to use the concurrent React, now it's called concurrent features with React 18 and stuff, to allow synchronous model in React Native. This is kind of interesting because before React Native is asynchronous, and now we're making React Native synchronous to allow async React. So let me repeat that. So React Native has been asynchronous and React was synchronous. We're reversing that. React 18 and concurrent feature is trying to be asynchronous, but in order to do that, we need React Native to be synchronous.
Wow.
So this is kind of like it's a funny kind of like the reverse direction kind of thing.
Yeah.
And in order to achieve that, we need to rebuild the entire UI layer renderer for React Native to allow flexible threading model. And that's Fabric in the architecture.
That's awesome.
I can just hear not all, but a lot of our audience being like, yes, this is going to fix. Because like the 1-2 frame flicker artifact, thing is just, it's so common. I think, Mazen, weren't you just telling me that you were running into something where you had to measure the size of something and the asynchronous? I mean, he's literally struggling with a problem right now on a project because of this.
Exactly. Yeah. And yeah, you just mentioned like everyone being like an on. Yes, I have the opposite. I'm like speechless right now. I don't even know what to go to next.
Yeah. I can add one more thing, which is like Fabric is the foundation. Like what I just described to you is the foundation to allow all this use case to be actually finally built. In order to make use of all this new capability, we need to integrate with concurrent React. So that's actually an active project right now, still experimenting to allow this kind of model. So at some point in the future, we'll be able to execute a certain layout or event for React Native synchronously. Like the most common example is text input, right? You have like inputs, and then you want to control what is on the screen. And sometimes you have like 1 frame delay of like things are not synchronized. This Fabric foundation is going to help us solve that. Fabric alone is not the solution, but it's a foundation to help us build more capabilities.
Is this available for developers to use now or still in development?
So yes, we are working to build a playbook, a comprehensive playbook for how you can adopt the new architecture, like all the way up to the second phase. And we're actively discussing with some partner, and we're planning to open it more widely sometime in the next year. Not exact timeline. We're still working on it, but we're working very hard every day to make it more available to all of you, starting with the new app. So hopefully in the near future and next year, you can start opting in your new app using a template from React Native to just try it out. We're not ready to announce that this is done. Everyone can use it widely anytime because there's a lot of pieces involved. Some library needs to be made ready to be the new architecture. Like there may be some changes that you need on the components or the modules, and we're working to provide the playbook for that. So hopefully by next year, everyone can just follow this and most modules can be ready.
One of the things that I think is on a lot of people's minds is this going to break our apps? Because when you roll this out, it sounds like a pretty significant refactor. How much of this are you intending to be backwards compatible with the bridge? And how much of it do you think that we're going to have to make some major changes to our apps?
Yes, good question. So let's break that into pieces. One, do you need to change your React components, like your actual product code? The answer is most likely no. We try very hard to maintain backward compatibility, so you can use the hooks, effects, and all of that fancy stuff. You can use that, and no problem. There will be some deprecated API because the old architecture have a bunch of, let's say, UI manager related API that is maybe not very well documented and maybe is not compatible. So we're working on guidance on how to migrate away from that. There is an alternative, but we just need to provide that in the playbook. So if you use a custom API like that, you might need to change something to something else, but that's about it for JavaScript. For the native side, for TurboModule, going a bit deeper here. So for TurboModule, your native module as is will work. However, you need to integrate the generated output that I mentioned before via codegen, just so that there's a type safety aspect. This means it's a bit of additional work on top of your module. You don't have to rewrite it though. So if you have a method that implements asynchronous whatever fetching of something, you don't have to change that. It will just work. We try to preserve the threading model as much as we can. Even with the old syntax, method queue for iOS and other stuff like that, we try to preserve that. In the future, we probably just going to remove it. But for the sake of compatibility, most of the time your classes will just work. You just need to add something. For render, the components, it's slightly different most of the time. For iOS, you can use the view managers as is. We have a backward compatibility layer that you can adopt to start with. And ideally, to get the most benefit for a no overhead, you might want to adopt the full Fabric compatible approach. It may involve some rewrite, just the base class. For Android, we try to make it as much backward compatible as possible with the view managers. So most of the time, no changes. So there are options. So I think we will leave it up to the people adopting this to decide, okay, how much do you want to adopt? Is it full capability, or just I just want to adopt and see what happens? Depending on how you set up your app, you may be able to enable the new renderer based on your root view. So if you have a system in the hybrid environment where you have multiple React Native root view, you may decide to enable Fabric one at a time. In fact, we did that for the Facebook app just to de-risk. So there's a lot of option, and all of these will be documenting and we'll be sharing playbook as we hash it out.
Perfect. Yeah. And one of the things that kind of comes to mind for me is I help maintain the React Native web view, and that has a ton of native modules. It also has a ton of native UI components. And so I guess there's in the back of my mind, like how much, like when you drop in a React Native web view into a brand new app that has all of this stuff enabled, how hard will it crash, And so that's something I guess that's just sort of top of mind for me.
Yes, good question. We try very hard to be backward compatible. So if you have a native module that is not ready to be Turbo module, we just execute it as if they're the old native module.
Yeah.
No problem.
Okay.
So like your app is fine. For Fabric, there may be some registration that you need to do, but like it's not it's not too big of a deal. But yeah, you can live side by side, basically.
Very cool. That's a big relief.
Yes.
So now, since you've released this new architecture on the Facebook mobile apps, what have been some pros and cons, I guess, as a developer or even from a user experience that you've seen come out from this?
Good question. So there are a few aspects with the new architecture and also for Fabric, which is one, type safety. So I explained before, we generate code from JavaScript via codegen, and then every part of the code adopt this, protocol or spec that provide a lot of build time type safety. So in the past, because we rely on the runtime checks and discovery, you don't know if something is off or misconfigured until runtime. But now, because everything is co-generated during build time, it guarantees everything to be in sync, assuming you're adopting all the output, right? So I think as long as you do the homework to just do that, the hook step, you can discover like, mismatch a prop during build time. Like someone changed a prop in JavaScript for the spec and then forget to update the native code, like it will fail during build time. So this is a big developer boost because this is a common mistake for many people that, I update this, but I forgot to update the other file kind of thing. And, vice versa. So that's one. Type safety is a thing. The Fabric, the render itself brings a lot of correctness. So the old architecture have a bunch of implementation and not everything is perfect. So of course there is like loopholes here and there in terms of when I set a prop here, what happened to actual behavior on iOS and Android. Sometimes they're different, like subtle different, but it is there. With the Fabric as the rewrite of the renderer, we had a chance to reevaluate some of these and sometimes make decision to like, okay, let's make sure iOS and Android is now consistent and it's more correct. And then if there is a kind of ordering or event ordering flaw that happened in the past in the old system, we had a chance to like reevaluate, okay, is this the right ordering? Can we actually do it properly? And, increase correctness basically. And like I touched on before, with Fabric, we can start building infrastructure to allow concurrent feature, synchronous access to stuff. Before in the old architecture, this is not possible at all. So we see one more thing. I mentioned before that everything is loaded lazily by default. This will help improve your app performance, startup performance. Obviously, it depends on how many modules or components you have loading, but we try to make it lazy by default, and then you can opt in to be more eager, or you can load stuff upfront as you like customly. But we try to make the default case to be more performant. So you get a bunch of this benefit. Some of them are direct benefits. Some of them are feature wins or feature capabilities that you will be able to use in the future as we finish the entire capabilities work. But a lot of benefits, really.
That's great. Yeah. I was reading the article that was released kind of about this new architecture, and I did see a lot of references to garbage collector. Do you mind going a little bit into what that is and how that ties into Fabric?
I believe that's somewhat separate. I believe in from the JavaScript point of view, there is a bunch of logic on how you garbage collect your reference. And then from the native side, like iOS have its own garbage collection. Let's just call it Arc. And then in Java, they have their own VM, and JNI have their own way to like release memory. So one thing we do here is that with the new architecture, we try to share the memory ownership from native to JavaScript a bit more. And by the way, this is possible thanks to JSI. And actually, if you just use the JavaScript API that exists on the platform, you can probably do that. But JSI make it more easier for us to like adopt this. So imagine you create a memory on the C++, which is hopefully tied to the native platform. And then we use that and pass the reference as is to JavaScript. And the JavaScript side, the React core will decide, okay, I'm going to hold reference to this for now. Later, with Fiber and the concurrent React stuff, I'm going to release it in the future. And then that's where the memory got released. I think the most relevant thing for the new architecture is that the fact that we start sharing memory more and more between the two worlds is allowing us to make this communication layer much more efficient. And, you don't have to have a copy on native and JavaScript. You just have one copy, and the JavaScript, the core React decide the lifecycle. And I think that's huge. That means simplified communication layer, and then having one entity that manage the lifecycle. I think that's great.
That sounds amazing.
Yeah, that is incredible. I'm blown away that this is even possible, but JSI unlocks a lot of things. Now, JSI, was that developed at Facebook, or is that something outside of Facebook?
JSI is developed inside Facebook, Meta.
Okay, cool. Yeah, it's a fantastic piece of technology.
So there was a couple articles that came out about the whole drive to React Native all platforms. With this new architecture and Fabric, what role does it play in bringing all platforms to React Native? And is this kind of like an improvement that will make it easier for us to go to the different platforms out there?
Yeah, very good question. One fundamental decision that we decided a few years back when we started the project is that the core renderer and infrastructure should be written in C++. At the time, C++ is the cross-platform language that is available, so we chose to do that, and it is already available in many mobile apps anyway, so we stick with it. So we built the renderer mostly in C++, the core infrastructure. Even TurboModule, the core system is in C++. So we interact directly with JSI, the JSI C++ API, right? So you see how all the core infrastructure is moving to C++, and then we're also trying to build a scheduler, a React scheduler that is in C++ on top of all of these infrastructure. So what this brings us is that with codegen and everything else and type safety across, C++ is a cross-platform language, so it's easier to integrate in different platforms, not just iOS, not just Android, Windows as well, and maybe and Mac OS, and maybe more OS in the future. That's one. Second, because of the codegen, we have control over consistency, type safety across all different platforms. So with that foundation, the hope is that we will be able to spin up a new platform, like a target platform, as just a mounting layer of the renderer. Mounting layer means that all the logic happened in C++ already. The core will tell the platform to decide, okay, hey, I need to insert a view here. I need to delete or remove or update something here. Do whatever you need on the platform. So at the end of the day, because of this cross-platform foundation, a new platform being onboarded into Fabric means they just need to provide the mounting layer on their own specific thing. And that's basically platform specific. So what we believe is that given all of these, it will make it easier for us to expand to more platforms in the future because of the cross-platform foundation.
That's great. That's awesome.
So all this stuff is built in C++. Did you have to go learn C++, or did you already know it kind of coming into Meta?
So I personally have learned C++ in the past, but not the modern C++. So I used the traditional pointer-based C++. The team had to spend months trying to learn C++, like especially modern C++, like what is smart pointer, what is the life cycle of exception handling and like RTTF and all that.
Yeah.
So yes, there is a lot of ramp up, and it was not as easy decision for us because when we started, we didn't claim ourselves to be a C++ expert. We actually learned a lot, and some people in the team spend like hours and weeks like learning from resources out there, like what is the good C++, what is the pattern, and try to bring the best of that into the Fabric and renderer. Yeah,
the thing with C++ that has always kind of like been a little intimidating. I know a lot of languages and I've learned a lot of languages over the years, but C++ has this massive API, and over the years it's sort of like changed what was idiomatic modern C++ over the years. So like if you learn something from a book like I did way back in the 90s and 2000s, like some of that stuff may apply, but some of it might be like, that's old school. You shouldn't do it that way anymore.
Yeah, definitely. And C++ is evolving as well. There is version 11, 14, 17, now 21, and who knows what else. So I think as the language mature, there's more like API that is built in that we were not able to use before. So at least for us, we're trying to find a good like middle ground on what is a good modern API to use, and then try to use that on the Fabric system.
On this podcast, we have a discussion that's kind of ongoing, I would say, about as a React Native developer, do you need to understand Swift, Objective-C, Kotlin, and Java to be an effective and senior engineer? I believe that was the discussion we had. Now that you're bringing in this C++ talk, do we now also have to understand C++ to be able to be more effective? Or is that just something that's completely under the hood and we just kind of focus on the native language and JavaScript, TypeScript?
Yeah. The new architecture does not require you to learn C++ to use it. As I explained before, we use code generation, so we take care of the layer that is in C++ for you. Most of the time, in the common cases, you just need to continue writing Objective-C or Java if you need to write the native stuff. Yeah, so I think it doesn't really add extra stuff. Obviously, now that there's a lot of C++, you have room. Maybe if you're interested, you have room to dig deeper into like, oh, how does this work? And then like maybe you can build something a bit more specific with C++ and like bypass all the system that we built in place, because we're trying to cover the default cases. There are always more use cases that can be unlocked. And if people and if companies or apps want to like explore that, it is a possibility. And we're trying to be flexible in this design, right? We're not locking you into like, oh yeah, you have to learn this for sure. But then provide flexibility by default. And so you can opt into like how deep you want to go in the different area. So no, in a nutshell, I don't think you need to definitely, I don't think you need to learn C++ like for sure. We take care of stuff for you. But it is definitely an opportunity to like dig deeper and maybe improve even further.
Absolutely. Yeah.
Mazen, I'm going to buy you a C++ book for Christmas.
Thanks. Yeah. I put it up behind me on my shelf. I'll put it right next to Gant's book. Okay. Well, Kevin, you mentioned a lot of this parallel work that's happening through the different phases through this project. And, given that you are the manager on this project, do you mind going through your experience managing this team, managing this project, and some challenges you might have gone through?
Yes, absolutely. So the idea of rewrite to some people is exciting, right? Oh yeah, let's rewrite. Of course, I like rewrite. But then if you look at the state of the world at the time, or React Native at the time, we are trying to solve a flawed old architecture with the async nature, and we're trying to rewrite that in place. What it means is that Facebook app at the time used React Native widely, and we want to continue making sure that product can continue running, no disruption, while rewriting all of these at the same time. So that presented a lot of challenges, because first of all, okay, how do you rewrite? You can build a brand new system, build a new brand new system, and then just test it later when you're done, and risk everything just not behaving as you like. So how do we do it in place, step by step? How do we build pieces by pieces slowly? So that takes a lot of iteration to learn, and also C++, right? We decided to learn C++. So like, how does my team able to like pick up this thing if we have to write it and pick up a new language and like rewrite and then like make decision while keeping all the products alive, like no disruption. So that's the fundamental challenge. So that's why quite a while to get it right. And then like we try to resolve most regression from different products. Sometimes it takes months to investigate like out of memory issue. Maybe we leaked something somewhere in the complex system. Took forever to find it. Sometimes product rely on the wrong behavior that I explained before. Maybe the architecture has some behavior that they just, oh yeah, this is great. I'm just going to use it. But then we fix it correctly that it breaks product. So who's right now? Is it the product or is it our infra? So then, obviously for every cases, we need to like do it case by case, and like we decide and maybe work with the product teams. Hey, let's figure out the path forward for this specific issue so we can move on, kind of thing. So from the management point of view, this is a lot of big scope, and I think it's great for people, for growth. People have opportunity to like create massive impact, stuff like that. So I think that's great. At the same time, the drawback, the challenges is that how do we keep people motivated to push through until the end?
Yeah.
So this is multi-year project. Setback happen. You try this. You try to build a small feature. You try in production, didn't work, and maybe that demotivate you. So how do we keep everyone like, yeah, we want to keep pushing and we want to continue, and like, and remember, Fabric is only the second phase. Like we have the third phase and maybe more stuff. Like the challenge is about let's keep moving, always move forward, and then like whatever happened, it's a learning experience. So it's all about that. It's many, encouraging people and, addressing setbacks. So that's what it looks like.
Yeah, it's a big project.
Yeah, and there had to be a lot of like internal, I guess, support from your management and whatnot in order to get to this level, because this was a lot of work. I can tell just by having talked to people on your team. It just seems like there definitely was a lot of work. But you're seeing the light at the end of the tunnel now, and it seems to be kind of getting close.
Yes. So one thing I can share is that we knew from the beginning that this is the foundation. So some people might find, how come I don't get immediate wins like on my surface? Because it really depends on how you write your surface, right? Or product. But then when we start experimenting with the new capabilities, concurrent features, and that on top of Fabric, then you found some of us finally got it. Yeah, this is why we built this thing. It's been a long time. It's worth it. This is why. So excited to share more when we're ready, but that's the time it takes us to get to this place.
Perfect. So one last question for you.
Sure.
And I have no idea if you can answer this or not, but I'm still going to hit you with it. Once this is fully rolled out, can we finally go 1.0?
We'll see. So I think so. From to explain from our perspective, 1.0 or 2.0 or whatever the number is, just a number. We always use the latest branch from GitHub. So Facebook app is always on the main commit at any time, which means what matters for us is that the main branch is stable. So however frequent we release updates, it is the most important thing for us, like to make sure that it's stable. So for us, at the end of the day, the label, the version number is just a number.
Yeah.
There's a lot of work for us to get to the stable place. Fabric needs to ship, the phase 3 needs to ship, and concurrent feature and other stuff needs to start getting built out. And maybe with everything stable, we will be able to start considering maybe 1.0 is more a reality, but right now is still far in the future, I believe, to be able to tell when or whether this still makes sense or not. But, again, to reemphasize, for us, it is very important that the tip of the tree is always stable, because that's how we move fast.
Yeah, that totally makes sense to me. I think the only place that this really matters is sometimes you'll get in a discussion with like a Flutter dev or something, and they're like, well, we're on 2.0. You're not even on 1.0 yet. And as some sort of like an indication of how stable it is, which, as we all know, there's no guarantee of stability just because something hits 1.0.
Yep, definitely. We try our best to make sure that the main branch is always stable within the Facebook app, and then so you don't have to do all the hard work. So that's kind of
Very cool. Well, thanks so much, Kevin. This has been fascinating. You've dropped a ton of knowledge on us all here today, and I really appreciate you coming on the show. If people want to follow you on Twitter or whatever, where can they find you?
You can follow me at Twitter, FK Gozali, or GitHub. I don't really check, or actively engage in conversation, but if you have something, just tag me and I'll try to respond as much as I can.
Perfect. Mazen, where can people find you?
At Mazen Chami.
And you can find me at Jamin Holmgren. You can go to the show Twitter at React Native RDIO. Thanks again to Kevin for joining us today. And as always, thanks to our producer and editor, Todd Worth, our assistant editor and episode release coordinator, Jed Bartosky, social media coordinator, Missy Warren, our designer, Justin Husky, and our guest coordinator, Derek Greenberg. Thanks to our sponsor, Infinite Red. Check us out at beardshollow.com.
No.
And a special thanks to all of you listening today. Make sure to subscribe on all their major podcasting platforms. We are React Native Radio. Also, reminder that Infinite Red is hiring React Native engineers. Go to careers.infinite.red. See you all next time.